So, here we see the example. In the case of bromination, we are looking at primary versus secondary formation, that is the proton is abstracted. We have one proton here, we have another proton here. So, in the case of let us say this is carbon number 1, carbon number 2, carbon this is carbon number 3. So, this is a propane molecule, let us say. So, in the case of propane molecule, we have 2 terminal carbons. So, that means 3 hydrogens on this carbon, 3 hydrogens on this carbon. So, total we have 6 carbons, and there is only one CH2, that is a central carbon. So, we have 2 hydrogens here. So, that means 6 hydrogens on the terminal and 2 hydrogens on the internal. So, the ratio is 6:2. So, if the halogen radical, that is if the bromine takes the one of the terminal hydrogens, then we are supposed to end up with the 75% of our final product, because there are 6 hydrogens are there compared to 2 internal hydrogens on the methylene carbon. So, this is the expected one, but unfortunately what is the obtained one? It is entirely the reverse of what we are observing. So, the internal one, we have 92% of the product that is formed by the internal abstraction and not by the terminal abstraction. So, why or what is the reason for that? The first one is, as we have seen, the bond dissociation energy is the one which is crucial. So, there is a difference between the CH bond broken here, which is 98, versus this particular bond we have 95 kilocalories per mole. So, this is the difference, that is one of the reasons. So, this is much less, so it can be easily broken, and the resulting radical stability also, when this product, this hydrogen is removed, we end up with a primary radical. So, here the product is going to be CH3 CH2 dot. So, this is the primary radical, and when this hydrogen is removed, the secondary hydrogen is removed, we are going to end up with a secondary radical. So, between primary and secondary, the secondary radical is more stable. So, these are all the 2 reasons the product formed is maximum in the case of secondary hydrogen, that is the secondary hydrogen in this particular case abstraction.